The first trip intending to land on the moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the moon. Take footprints, for starters. I know they're not technically objects, but the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped two objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit two golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the moon. There's yet a message from Queen Elizabeth II there. The monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully will return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the moon and come back to Earth. This was a test drive. Before NASA transports people to the moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube.
It's been decades since the last manned moon landing, Apollo 17, which happened in December 1972. Isn't it time we thought about going back to our dusty satellite, and maybe even staying there? NASA has made a promise on this subject. They're preparing to send astronauts on the moon again, perhaps by 2025. This will all happen through a program called Artemis. It's also going to include the first woman ever to experience the lunar surface. Now you might ask, why haven't we done this already? One former NASA administrator said something interesting on the subject. It's not because of scientific or technological issues. Problem was that the potential projects took too long and were just too costly. You see, space travel, especially when it involves humans, isn't easy on the pockets. It's true that, in recent years, NASA had budgets of billions of dollars. Sure sounds like enough money, right? Well, not when you check out their to-do list. That's because they have to consider everything. From telescopes and giant rocket projects to missions also targeting the Sun, Jupiter, Mars, and beyond. When you look at it this way, NASA needs to be very good at budgeting to achieve all those goals. It's not just because of finances, though. The moon itself is quite problematic. It poses real dangers that cannot be taken lightly. For starters, its surface is filled with craters and boulders that aren't easy to land on. Then, there is the moon dust, or regolith, if you'd like to call it by its scientific name. It was created over many years by meteorite impacts. It's extremely harsh and sticks to everything. It can potentially damage spacesuits, vehicles, and systems quite quickly. Also, dealing with the lunar habitat isn't a walk in the park either. The moon has no protective atmosphere. What this means is that for 14 days at a time, the lunar surface is faced with harsh rays from the sun. That period is followed by another 2 weeks of total darkness. All these changes create extreme temperatures, which us humans are not really accustomed to. There are solutions, don't worry. NASA is working on dust and sun-resistant spacesuits and vehicles. They're even developing a system that might supply electricity during those lunar nights. What's even more interesting about this system is it could come in handy on Mars too, once we get there. NASA also needs to draw in really smart people for its projects. Think about it. The average age of the people working for the mission control for Apollo 13 was just 26 years old. And these people had already been part of numerous missions by that time, which means they'd had considerable experience from a very young age. But here's where other individuals can help too. In recent years, it wasn't just NASA who's been working tirelessly to revolutionize space travel. There are many successful people out there with enough resources to join in on these efforts. Some are developing new types of rockets that can land on the moon too. In total, NASA landed 12 people on our satellite. It's definitely one of the most awesome moments in its history, if not the best. And those astronauts did amazing things up there. They brought back rocks, took snapshots, did science experiments, and even left flags behind. These were all important moments of the Apollo missions. But they weren't meant to create a safe place for humans on the moon. Scientists have had this idea of a lunar space station for a long time now. It's only logical. After all, it's just a 3-day trip from Earth. It means we can, technically, afford to make little mistakes here and there, without messing up the whole project. Plus, we'd learn so much before venturing even further into space. A moon base could provide fuel for deep space missions. We could also build telescopes up there and launch them way easier in space. It could also help us in another important project: figure out how to make Mars habitable too. Not to mention, a lunar space station would help us learn more about the moon's origin. Who knows, it could even bring in some money because of all that fun, exciting lunar tourism. Either way, the Apollo moon program took a lot of work. For starters, let's look at the sheer number of people involved. Around 400,000, from every corner of the states. Not everything was picture perfect, tough. There were two main unfortunate events. Firstly, a fire mishap at the launch pad of Apollo 1. Secondly, an oxygen tank decided to throw a tantrum on Apollo 13, causing severe issues mid-mission. An important part of the project was Saturn V. It is to this day the most powerful rocket flown successfully, being 36 stories high. Still finding it hard to picture? This rocket stood twice as tall as Niagara Falls. Thanks to Saturn V, NASA successfully completed 13 missions. This included chauffeuring 24 astronauts towards the moon, with half of them even having a little walk on its surface. The existing rockets and space shuttles can't go beyond low Earth orbit. In simpler terms, they can't reach the moon with all the gadgets astronauts need to thrive. Current space vehicles are just not capable of carrying that load, at least not since the Apollo missions happened. Regardless, we did make a lot of progress on Earth and are ready to send astronauts to our satellite pretty soon. Here's where the Artemis project comes in. It's a program overseen by NASA. And to make sure it all goes well, NASA previously launched Orion, a spacecraft with no crew on board to orbit the moon and return to Earth. Think of it as an automated test drive. Before we actually send people out there again, we need to make sure all the devices work properly. One day, Orion will be the vehicle that will take astronauts to the moon again. It features a launch abort system to keep astronauts safe in case something bad happens during launch. It also has a service module, which is the powerhouse that fuels and propels Orion and keeps astronauts alive with water, oxygen, power, and temperature control. All these future projects make one wonder, what will life on the moon be like anyway? We can only use our imagination for now. Some say we'll be living in homes straight out of a fairy tale, something like a cozy hobbit hole. Living underground on the moon might be a must. That's due to the scorching temperatures and the lack of oxygen. If you add meteorite threats and the non-stop radiation, it's no wonder we can't just walk on its surface. What about transportation? Big and small companies alike are trying to create the ideal moon ride. If current estimations are current, one type of moon taxi will take off as soon as 2024. Unlike our current rockets, these space taxis won't have to deal with the harsh conditions of re-entering Earth's atmosphere. It will be easier for them to make multiple round trips. To support our lunar living, we'll need to have a special area for space taxis to safely take off and land. Think of it as a landing pad on a firm, flat stretch of moon surface, protected by walls to shield against moon dust. Moving around on the moon's surface will be made easier too. The next generation vehicles we're talking about will have their own controlled environment, which means you won't need a spacesuit while inside. Should feel like stepping out of your space ride for a bit. Then of course, you'll need to put on your spacesuit. All right. So we've got our homes and our rides sorted. But what about fuel? That's where the moon throws us a lifeline. The moon's lighter gravity means we don't need as much power to escape its pull. Plus, the moon has ice, and that's super handy. We might be able to convert this ice into rocket fuel. We'll need dedicated space gadgets to help gather this ice. One such tool is called Trident. It's like a drill, perfect for digging into the icy moon surface. Additional robotic helpers would then turn this ice into fuel and deliver it to a space gas station. If this works, rockets on their way to Mars could stop by for a quick fuel top-up before continuing their journey.
Have you ever seen the other side of the moon? I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the two sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Lunar missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important though. The formation of this basin was a defining event in the history of the moon, and it's the second largest impact crater in the solar system. The collision also caused a powerful hot wave to spread across the moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscovians. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So stay tuned for new exciting research and discoveries. In the near future, people have made the greatest space discovery in history. The entire population of Earth looks up to the sky to see the greatest astronomical show ever. Is this real? What does it mean? Scientists have been studying galaxies, planets, and black holes millions of light years away. But all this time, something fantastic has been hiding in plain sight right above our eyes, on the Moon. Starting a few years ago, humans began going to the Moon again and finally set up a permanent base there. While excavating the lunar landscape, one lucky drill smashed into something like a metal plate. It turns out that metal contains polycarbonate, aluminum, gold, and silver. That's very similar to something humans already have on Earth. It's basically what CDs are made out of. People start going excavation crazy. Who knows what else is down there? The Moon turns out to be our greatest resource. After a few months, lunar construction equipment has excavated several hundred feet of the shiny surface. At first, it was kept quiet, but a year later, that becomes impossible. Excavation crews dig out a huge rectangular shiny piece, the size of 10 football fields. And that plate is not alone. There are literally millions of them. After a little more research, scientists discover that the entire surface is covered with this strange material. People gaze up every night at the unusual Moon in the starry sky. It glows a little brighter than before. You only need the most ordinary telescope to see that things are about to get weird. The excavation work isn't complete, but scientists have concluded that the Moon is a huge disco ball. Who created it? For what? And what does this mean for us humans? No one has any answers. Soon, humans managed to dig up more than half of the Moon. In some places, the plates are too deep to get to. They're stuck under mountains. In other places, the plates of the disco ball lie directly under the surface. Somehow, even with this crazy discovery, the properties of the Moon haven't changed in any way, except that it's become brighter. Attempts to dig deeper, to pierce through the plates, are hopeless. The layer of polycarbonate and metal alloys is too thick and seems to go deep into the core of the Moon. Some scientists suggest that if the Moon's surface resembles a CD, it might just mean that there's some information recorded on it. That would change the course of history. They decide to build a laser reader to see if the Moon really is a whopping big CD. Meanwhile, the drilling continues. On the dark side of the Moon, which isn't always dark by the way, people find a small crater. Surprisingly, there's no shiny material inside. This perfectly round hole looks like a dried-up lake. At first, everyone assumes that there was a plate there. It just must have flown off somehow. But then, why was that crater so perfectly round? After a little more investigation, diggers find something that looks like plastic. What's that all about? Then, unexpectedly, the digging stops. The huge rig smashes against a thick alloy of unique durable plastic. There's a perfectly round plastic disc hiding inside the crater, the only one on the entire Moon. It becomes clear that this huge disco ball was created by something billions of years ago. It's been covered with cosmic dust ever since. IT specialists scan the entire lunar surface with the help of satellites. They find something. It looks like there's a complex electronic system hidden under the disk. If you look at the moon as a whole, the crater starts to look an awful lot like, well, a button. Time to press play on the moon. To understand what's going on there, scientists try to get through the plastic layer. While they're doing that, there's an accident. An automatic drill explodes under insane pressure. The blast is so strong that it activates the button. All of humanity freezes in fear. There's silence, real silence. Then, it happens. The moon starts to rotate ever so slowly on its axis. Then, hour after hour, it rotates faster and faster. There's a mad rush to get everyone off the moon. Soon, it'll be spinning too fast to take off from safely. A lot of people fly halfway across the planet, where it's night, to see what's up with the moon. Every TV channel, website, blog, vlog, live stream, everyone's broadcasting the same images, those of the great disco ball in the sky. The moon begins to spin so fast that all the loose rock and sand on its surface gets scattered in different directions. Some lunar fragments fall on Earth and create an incredible meteor shower. The moon is spinning faster and faster. Now it looks like a real disco ball. The night sky is lit up with bright rays of white. It's incredible. People are ecstatic, amazed, delighted. But a moment later, all of humanity descends into a deep state of fear. Astronomers report that the moon is approaching Earth. When it gets too close, Earth's gravity will destroy it, and the giant crushed-up disco ball will smash into our planet. Every hour, the moon gets bigger in the night sky. Floods are starting to break out all over the world. People dust off their underground bunkers and get inside. There's no time to blast the moon with a rocket or anything like that. This could be it. The moon creeps closer and closer to the Earth's atmosphere. Then it stops, and nothing happens. Incredible! The disco ball isn't affected by our planet's gravity. Some sort of ancient technology inside the moon just saved us from disaster. Then, a deafening sound booms out from the night sky. It's coming from the disco ball. The sound wave obliterates all the clouds in the sky. It sounds like a roar, a deafening bass that makes the ground shake. It's intimidating, scary, but then a rhythm starts to come out from the wall of sound. Impossible! There's music coming right out of the moon. Then some plates start to change color. They turn purple, pink, blue, green. It looks wild. The different color rays dance around on the Earth's surface. It gives everyone an insane energy boost. Everyone wants to be outside with friends, neighbors, anyone. One moment you're standing under a green glow, and a second later, everything around you gets lit up in pink. The incredible light show creates an unbelievable desire to dance. DJs around the world team up to record a whole new sound that mixes with the moon's music. They call it MLB, the Moon Light Beat. People all over the world go out into the streets and kick off the biggest party ever. Scientists now think that billions of years ago, our planet was inhabited by huge intelligent beings the size of Mount Everest. They wanted a party and set about creating a huge disco ball. Then these creatures moved on to another planet. Earth was getting kind of cramped, and the disco ball was simply forgotten. Over millions of years, dust and rock obscured it from view. For several months, the moon continues to spin, and DJs keep pumping out music. People start to get a bit tired of the whole thing. They want a bit of silence and a calm, starry sky, not a glittering moon disco ball. Humanity starts experiencing mass insomnia and dizziness. All flights are grounded because the bright colored flashes make it impossible for pilots to see properly. Unfortunately, no one knows how to turn this thing off, and it's impossible to study because the moon's moving around too fast. The problem is solved by itself. The ball stops and returns to its orbit. It's possible that it just ran out of battery. People aren't exactly in a rush to reactivate it, but they leave detailed instructions for their descendants in case they want to throw a global party.
It all started with a minor change on our planet. At first, people noticed the moon had become brighter and a little bigger, but nobody paid attention to this. The moon affected tides all over the world. The water flooded the beaches, but it wasn't a tragedy. A lot of fish came close to the shores. People found giant squid, anglerfish, and other creatures next to the coast, although they usually live in the dark depths. New, stranger things happen every day. Birds no longer fly to the south in winter. They gather in huge groups, flying around cities with no purpose. The moon used to help them navigate in nature, so they can't figure out which way to fly anymore. In the boundless waters of the world's oceans, ship captains notice that compasses are now unstable. The arrow is pointing in different directions since the Earth's magnetic poles have changed. People realize the moon has started to approach Earth for an unknown reason. The moon's gravity affects the gravity of our planet. This entails changes in the climate, the behavior of all living beings, and the magnetic field. Now, it rains in the driest places and gets hot in the coldest lands. It's knocking down ecosystems all over the planet. People living near forests hear wolves howling all the time. The moon drives these animals mad. The Earth's natural satellite is growing in size and lights up the night much brighter. Nothing critical has happened yet. People don't panic because they don't want to believe the end is coming. But then, one day, the moon reaches a critical point. You're walking down the street listening to music, and at that moment, someone pushes you. Okay, maybe that guy is late for work. You keep walking, and a girl coming by hits your shoulder. "I'm sorry," she says, and goes away. You've noticed the fear in her eyes. You look ahead and see people running towards you. You take off your headphones and hear screams and sirens. People leave their cars and run away. Hundreds of seagulls are flying in the sky. You hear a strange noise among all the sounds of chaos. It seems to be water. How is this possible? You're in the city center, a few miles from the shore. But there's no time to think. You notice a huge wave flooding the streets and heading straight to you. You run into a building and go up to the 10th floor. From here, you're watching the water filling the city. The strong stream blows all cars, one-story buildings, and trees off the road. You notice a shark and other fish in the water. People are hiding in houses and on the roofs. The whole city is quickly plunging into a catastrophe. The TV is working in the building where you're hiding. You learn that floods are occurring all over the world. Massive tsunamis cover coastal cities. In some places, waves reach the height of a 30-story building. Many towns have been washed off the face of the earth. The moon is too close to Earth, and massive floods are just the beginning. The moon flies around Earth and helps to keep our home on its axis. The moon provides climate stability and helps living organisms develop. But now, this balance is broken. The moon is approaching and changing our planet's gravity. Earth can tilt slightly to the side and provoke massive floods around the world. Imagine that you're holding a round glass of water. Tilt it a little. See how the liquid moves from one side to another? The same thing is happening now with the oceans. But the moon is not just approaching us. It's flying around the planet and getting closer with each circle. It causes natural disasters in different locations on Earth all the time. Now the ocean floods one side, and a few hours later, another. So you see all the water going back from the streets to the shore. The oceans may return to the city again by the end of the day. Wait a minute. It seems the end of the day has already come. You notice that the sky has become dark. It's weird, because it's only 3 p.m. The moon changes Earth's rotation speed and makes the day go faster. The moon covers almost the entire sky and brightly illuminates our planet. You see huge lunar craters. It's so close that you can still see it even when the sun shines. In some places, the passing moon obscures the sun. The water is leaving the streets and everyone goes outside. At this moment, an earthquake begins. The road is cracking and the houses are collapsing. There are landslides on the street. Tectonic plates are shifting all over the planet. Imagine two magnetic balls that are approaching each other. So, one ball is the moon and the second one is Earth's core. What do you think will happen to what's above the core? That's hundreds of thousands of miles of the Earth's crust. And now, it's all moving. Destructive cracks are emerging all over the world. The planet's highest mountains break down and turn into a pile of stones. The seabed cracks and releases magma from the underground depths. Volcanoes wake up and erupt magma. Clouds of volcanic ash cover the sky from the sun and the glowing moon. But the scariest thing is still ahead. A collision is inevitable. The moon flies around the planet like a ball in a round glass with a hole in the center. This force drives clouds all over the planet. Now there's a thunderstorm, but in 5 minutes, it will be snowing. Then the night comes, and it starts raining. Water droplets consist of mud and volcanic ash. It's difficult for people to breathe without gas masks. Atmospheric pressure is constantly changing. Some people experience severe migraines, and some have sore joints. But there's no time to think about your health. Humanity needs to figure out how to save itself from the collision. A new gravitational order will come when the moon crashes into Earth. Continents will change their shape. They will combine into one giant piece of land or split into 100 smaller ones. The energy of the collision can burn all the oxygen in the atmosphere and make the planet unsuitable for life. Hiding underground also makes no sense because of deep earthquakes. People decide to spend their last hours with loved ones and their families. The moon is getting closer. It's now at the same distance as the International Space Station. The moon covers the sky. Many cities are in the shadows because of the waves. Tsunamis, several miles in height, crash down on the ground. Millions of tons of magma collide with the ocean. Billions of gallons of water just evaporate. Moisture rises into the air, mixes with ash, and floods the land in the form of giant cumulus clouds. You've accepted the complete destruction of the planet. But something strange happens to the moon at this moment. You notice giant cracks appear on it. The moon slowly begins to divide into two parts. Both halves crumble into hundreds of large pieces. It's just falling apart. The Earth doesn't have a natural satellite anymore. It's just a pile of giant space rocks. But why is this happening? There's a space around our planet called the Roche limit. In this place, the gravity of Earth is stronger than that of the moon. This means that the forces holding the moon together are weaker than those that tear it apart. People are cheering. The Roche limit has saved the planet. The moon won't hit us. It breaks up into millions of fragments and forms a circle around our globe. Now, Earth looks like Saturn. A belt of moonstones surrounds us. Huge chunks destroy everything in their path, all the space debris. The satellites are no longer working. Humanity loses its means of communication and navigation. People will have to use paper maps again. The moon held our planet's orbit at a certain angle before these events. Now the axis is tilted differently. One hemisphere becomes closer to the sun, and the other plunges into shadow. The North Pole and the Arctic may turn into hot deserts, and the equator of the planet may be covered with ice. Winter and summer can last for years. The moon's remnants fly around Earth, but some of them fall on our planet. Lunar meteor showers destroy cities and create giant craters. All these events lead to the massive destruction of life on Earth. It will take hundreds of thousands of years to adapt to the new world.
How was our universe born? And if this seems hard to answer, then how about this? What was before our universe? While scientists are looking for the answer to the most difficult question in history, let's find out what they've come up with so far. In the 20th century, we've shed the light on this mystery, all thanks to this man, Edwin Hubble. One day on Mount Wilson in Southern California, he aimed his telescope at the sky and found out that these random clouds of gas flying everywhere are actually other galaxies, and there are a lot of them. And also, he learned something else, something that changed the world forever. They're moving. So what, you may ask? Well, it meant one very important thing. The universe is expanding. And if it's expanding, then it probably had a beginning somewhere, right? Now, all we have to do is run time backwards and see where the beginning was. It took the scientists many more years to come up with a full-fledged theory, the Big Bang Theory, and here it is. Nothing has ever been anywhere because neither when nor where existed. Do you get it? But actually, no. There was one thing. It was the so-called cosmic singularity, a state of our universe in which it was incredibly small, dense, and very hot. Imagine if our universe was compressed into a small ball. The pressure and temperature inside would be enormous. At some point, it became impossible to withstand them. And here comes the Big Bang. It was an outburst of energy and matter that created everything we see now. Time and space, basic physical forces. It also scattered quarks everywhere. These quarks, tiny particles that make up our world, were all boiling in an incredibly hot cosmic broth. When it cooled down, gravity began to attract them to each other. They gathered into atoms, then molecules, and then into the first objects into the world, stars. And all this happened just some 12 to 14 billion years ago. Alright, now we know how our universe was created, but what was before that? Alan Harvey Guth, an American theoretical physicist and cosmologist, has devoted his whole life to solving this mystery. After learning about the Big Bang Theory, Guth found some flaws in it. For example, the distribution of matter was very even, although it shouldn't have been. Let's hang a balloon filled with paint to the ceiling and lay a white canvas on the floor. If we drop the balloon down, it will burst and we'll see absolute chaos on the canvas. A bunch of spots scattered everywhere randomly. Neither is like the other. But that's not really what the universe looked like. Instead of throwing a colored ball from the ceiling, let's draw a small red dot on the canvas. Now, let's expand it a little more, and capture this all on frame-by-frame shooting. We'll see a circle gradually growing in all directions. That's the reality. The early universe was very even and proportional. That was Guth's discovery, the theory of inflation. Here's what it says. Even before the Big Bang, there was some kind of force that could give the bang a strong acceleration, something that was able to distribute everything in space instantly and evenly. Guth's theory was a success, and now most scientists rely on it. For most of them, this idea of the birth of the universe is quite enough. For most, but not for all. Martin Buewald is a German professor of physics, and, in his opinion, the universe was born quite differently. Remember when we talked about cosmic singularity? The state of the universe in which it was small, infinitely dense, and super hot. According to Martin's theory, the singularity couldn't just appear out of nowhere. This is nonsense. But then, where did it come from? Let's look at a pendulum on an old clock. The pendulum rotates back and forth. Its movement is smooth, continuous, and non-stop. This is how we usually see time. It flows and never stops. But quantum time, quantum time doesn't work that way. It's more like the second hand of a clock. It consists of small segments and makes short pauses. And just like with the second hand of a clock, the beginning of one segment of time is always the end of another. See what I'm getting at? Let's go back to balloons again. According to the Big Bang Theory, once upon a time, our universe began to expand, inflate like a balloon. But sooner or later, it will blow away back. The universe will start shrinking and return to the state of cosmic singularity. And then guess what? The Big Bang too. Nothing appears out of nowhere and disappears into nowhere. According to Buewald's theory, the beginning of each universe is the end of the previous one. Our universe is not at all the first and not the last. Millions of similar universes existed before us and will exist after us. This theory, although it sounds very logical, is far from complete. Unfortunately, we don't have enough knowledge to find all the evidence for it, so for now, all this is just a hypothesis. But some people come up with even stranger ideas. Scientists promote such unusual theories that no one could even think of. Neil Turok, a South African physicist, and his colleague Paul Steinhardt, an American theoretical physicist, look for answers far beyond our universe. They say that yes, our universe isn't the first one. There have been and will be an infinite number of them. And not only will there be endless Big Bangs, our universe is just one of an infinite number of others. And all of us are stuck in a cycle of endless rebirths of parallel worlds. This sounds incredible and frightening at the same time. But how does it work? According to this theory, our universe is located inside a so-called brain, as in membrane. In other words, we're stuck in some kind of elastic surface that's capable of contracting, stretching, oscillating, and so on. Like pieces of fabric on a rope, these parallel universes are located near each other. Each one has a neighbor. We're not the exception. Another universe may be an inch from ours, but we can't see it. That's because there's a tiny space between us, and this tiny space contains the fourth dimension. How do these universes originate? Through brain collision. These brains are getting closer to each other very, very slowly, until one day they finally collide. Their collision creates two Big Bangs and two parallel universes. Then they're moving away from each other. The created worlds continue to live. We're currently at this stage. But when they disappear, the brains collide again. And this will lead to the birth of a new universe. Remember the inflation theory? There was a mysterious energy that pushed and accelerated the Big Bang. Well, if we did collide with another universe, that would explain everything. Of course, everything described here is a great simplification. When you hear that our world is some piece of fabric on a rope, it sounds like complete nonsense. But this idea is based on string theory and M theory, two giants of quantum mechanics. If they turn out to be true, they could explain almost everything in our universe. Creating a theory is an incredibly huge process. Turok and Steinhardt made a huge amount of calculations and swept away many non-working theories. Also, to work this out, they have to overcome the limits of the human mind and think in 11 dimensions at once. Unfortunately, this crazy and elegant idea was laughed at. Turok and Steinhardt say that scientists are regular people, just like everyone else. They're also afraid of change and the unknown. And it's really scary to question everything we once believed in. Many years ago, people didn't believe that the Earth was round. Then they were outraged by the Big Bang Theory. We can't make discoveries without struggle and fear. That's why Turok and Steinhardt don't plan to give up so easily. After all, the evidence that we have now only says that each of the three theories is equally possible. So which answer is correct? We may never know, at least not at this stage of human development. Unfortunately, as long as we have no evidence, we can only theorize. But maybe one day we'll find something that will open our eyes once and for all. Maybe one day we'll solve the mystery of how our universe came to be.
Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila! You're flying to the stars, all thanks to nanotubes. But then something hits the elevator on the way. You're stuck inside, and now you're doomed to float in space forever. Now, if you want to travel in space, get ready to shell out around $55 million. But in the near future, you'll probably be able to travel to space with just the push of a button without breaking the bank. Because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, the Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. The station from where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around the Earth like a scarf. Also, the orbit the line would be following should be a perfect circle, because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a second, there's a use for algebra? Never mind. Meanwhile, I won't bore you with the math. We'll go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 22,236 miles above the Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit, and the conveyor dumbwaiter host would not work. So, we need to balance the station in space to ensure it worked flawlessly. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel. But when you need a 22,236-mile-long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because, at the endpoint, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.5 inches. After using some complicated math, we can figure out the thickness at the end, which is a number so long I am unable to pronounce it. But believe me, it's a big one. So, steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 262 to 557 feet. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build a cable, the idea of the space elevator will just be a massive waste of time. If only we had some magically light material with a power of 60 gigapascals, which would have a taper ratio of 1.6. Oh wait, we actually do have this unique material. It's called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than a human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics, and it can be modified entirely and adapted for more uses. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, "Don't do anything too crazy and start building a space hoist." I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer, so we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. In the future, space tourism could be totally possible. Who knows? We might even go on vacations in space. Hey, looking for some atmosphere for your getaway? Well, don't come here, we don't have any. Oops, probably not a good advertising slogan, huh? Meanwhile, a couple of years ago, we could only create microscopic carbon nanotubes. But as time went on, much more research was done to make them bigger. Now they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we would need around $1 billion to build a lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Now, everything looks perfect on paper. But NASA's main reason why they chose not to go along with this project is that right now, there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. Now, if something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining, too. We could easily cover the cost of the entire elevator by collecting asteroids, because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth.